Yeah. So any questions, any doubts before we proceed?
Yeah. Yeah. Hi, Srinivas. This is Shantan here. Actually, I joined today, 3 days
Yeah,
late.
yeah.
So,
Yes, yes, understood.
yeah. Yeah. Actually, I was just going through all the
Video.
meetings. Yeah.
Yeah,
Yes. So I was just taking a look. I just wanted to know that can you just tell me brief about it, all those models and what is the difference? How to generate models?
fine,
You were
fine.
saying in the last meeting, right?
Yeah, that is the complete session. How to generate models,
Okay.
AI models is a complete course. We'll discuss that. I'll explain. Yeah. Srinivas, any doubts?
Can I get access to the old videos, last couple of sessions, I guess?
Sure, sure. I'll do that. Soon after the session, I'll do that.
Yeah, so it might take some time for me to catch up.
Yes, sure, sure. Okay, so let me start then. So you can see my screen. I'll just give you a brief idea, then we'll move on to the actual class. Okay. Just five. I don't take more than 5 minutes to brief about it. So here we got transformed from data to big data world. Big data got generated due to IoT, Internet of Things, where we have every object, every company, every user connected to digital world. So wherever you see velocity, volume, variety, value, veracity, that data we called as a big data. By 2025, we will be seeing 325 zettabyte of data. So one CD is equal to one zettabyte is equal to one CD to every person across the globe. Then artificial intelligence has become famous because of big data. Artificial intelligence is nothing but transferring human intelligence to objects to think like a humans, like recognizing speech, making decisions, and identifying data patterns and predicting categorizations, classifications, there are many things. AI is a part of now every domain, everywhere. Then artificial intelligence can be achieved with the help of machine learning. Machine learning is a part of artificial intelligence, is subcomponent. So where we have multiple types like supervised learning, unsupervised learning, and reinforcement learning. The machine learning uses algorithm trained on the data that we called as a model. Model is nothing but algorithm trained on the data. So this model can be used for predicting, classifying, categorizing without any manual intervention or any human intervention. Okay. So machine learning types are supervised learning, unsupervised learning, reinforcement learning. So, but these machine learning algorithms will work only on numerical data and transactions. What if you have images, video, speech? Okay, that is where we have a deep learning algorithms. Or deep learning, ANN, CNN, RNN. These are different types. ANN means artificial neural network. Artificial neural network. CNN, convolutional neural network. Convolutional neural network. RNN, recurrent neural network. Like this, we have multiple deep learning algorithms. But deep learning algorithm architecture is artificial neural network architecture. It is derived from human neural networks, human brain, inspired by human brain, where interconnected nodes called neurons. Each neuron we call it as a computation engine here. You can see neurons. These are all computation engines. which are there in our brain. So deep learning is inspired from human brain and created artificial neural network architecture to process the complex data like video, images, and audio. Okay, so now we understood that deep learning is a part of machine learning part of artificial intelligence. So what is the next expectations of human being? This is where people are expecting to create a text generation, image generation, video generation, code generation, music and speech. For example, you are a story writer, you know the subject, it can prepare text for you. Or after preparing subject, after preparing story, you want to break that into multiple simple statements and prepare images, you can prepare images. Or you want to prepare a video, you can prepare a video. You can prepare a short film. Or you want to write a code, you can write a code. You want to build a new music, you can build a music. You have already been hearing all this one on the social media that people are able to create a different variety of videos. You already experienced it and speech, but we are going to use these techniques for our enterprise applications for our clients. Okay, that is where we have a generative AI. So this is the created by generative AI. It is a new technology. New technology means it has become so famous now. Of course, it is a old technology released 1960 itself, but here generative AI has become popular after introduction of ChatGPT by OpenAI. You already know the generative AI is first released by Google, OpenAI, Hugging Face. These are the main people. Then later on Amazon, then many other companies, Midjourney, Mistral, many other companies released Perplexity, released their own LLM generative AI models. Okay, so generative AI means generate a new thing with the help of artificial intelligence. So this is the evolution of generative AI. First they started with artificial intelligence, then machine learning, then deep learning. Now with generative AI. So generative AI is a part of deep learning part of machine learning part of artificial intelligence. So how the generative AI functions? So here we see roles and users. So these will be having questions, doubts, assumptions. We'll prepare a prompts. There are different techniques, different methods. There is a discipline in it. It is a separate module in our course. So we will be discussing in depth of prompt engineering. Then these prompts will be entered as input to generative AI. This is where you have a large language models, LLM model. We call them as LLM models, large language models. These models will use these prompts and generate the response like this. If you ask for text, it will give you text, image, video, code, music, speech, anything. These are the outcomes of generative AI. It's a very simple working model. Let me know if anybody has any doubts, questions. Any questions? Divasri, Somit, Guru, Banu.
Hey, Sri, Sudhakar here.
Yeah, Sudhakar.
I have a question regarding the one of the concepts. You said like hyperparameter tuning.
Hyperparameter is to fine-tune the large language models.
Right. I was just looking for, you said like, it's external parameter. We are not going to utilize, any part of the coding. And can you give me any real example in where exactly we are going to use this?
Yeah, I will definitely give you, but that way far for our syllabus, but definitely I will give you that now. Okay. So
Okay.
other people, please don't get confused. We will be anyway going to discuss. Since he has asked, I'll try to answer the question. But anyway, after 10-15 classes, we'll be discussing that. See, hyperparameters, for example, hallucination. When you ask something in ChatGPT, sometimes you don't get exact answer, right? So what you
Right.
do, you again ask a different question. So even that time also you're not satisfied with the answer. Again, you try to ask different question. I mean, you frame in different way. That is called a prompt tuning. So you are going to apply different prompts, okay, and passing to model, making sure that model is giving a response. Otherwise, model will try to hallucinate the output. Okay, to reduce the hallucination, So we'll be using hyperparameters technique. Okay.
Okay.
So one is temperature, another is top P, top K. We will discuss all that. Not right now.
Yeah,
That's a part
sure.
of LLM coding. Yeah.
Yeah, sounds good.
Yeah. Any other questions, please? Okay. So this is the main difference between machine learning and generative AI. Machine learning, we do predictions, recommendations, classification, clustering, fraud detection. We prepare models from scratch. We write a code. But generative AI, we do the text generation, image generation, video generation, speech, code generation, code refinement or use cases. Then have foundation models. So this is where we talk about LLM models, predefined models. So we don't need to write any code to build the foundation models. Foundation models are already available. So I will show you what are these foundation models. So here you can see one set of foundation model. You can see here. Yeah. This is from Gemini foundation model. Right side, you will see here on my screen, this is a one foundation model, LLM model. Okay. If you open this one, you will see multiple models. So I'm giving you the link just to open in your machine and save this link. We'll be referring this one. Click on this link, please, all of you. You're able to open it? Let me know. Okay,
Yes, sir.
you're able to. Okay, very good. You can log into your ID. Okay. Then I'm going to give you another one. This is from OpenAI company. Look at the right side model again here. Okay, these are different models. You can choose any model. This is from OpenAI. I'll give you this one also. This one also, please. Yeah, save that. Then this is another one. Save this one also. Models. These are all LLM models. What you see here, foundation models. What we have seen. What we have seen. So left side you will see all categorization. This is from Hugging Face.
Can you repost okay? Can you
I'm
repost
doing.
those because I disconnected and rejoined?
Oh, okay, fine. I'll do that.
Yeah, it says some server error and it
This is the
disconnected.
first one. This is the
Okay.
first one, and this is second one. This is third one. Okay.
Okay.
Yeah. Okay. All of you saved it.
Yes.
So these are the foundation models. What I showed you. These are different from machine learning. You don't need to prepare those models. Already we are using available models. Okay. But what are we going to do with these models? We are going to create a code, refining code. We are preparing use cases. We can prepare a speech, video generation, image generation, text generation. Got it? But how these models are going to work internally? With the help of transformer architecture. That is kind of a task specific. So generative AI, any generative AI component or model is based on two things. One is a task specific, another one is generative GAI. Task specific means which will refer a transformer where you will be having a complete end-to-end architecture. We will be discussing this transformer architecture. Otherwise, you can use generative GAI models like a generative adversarial network, variational autoencoder, diffusion model, flow model. Similar to the model, here you can see the models, list of models like this. Based on the need, audio related, these are all audio related models. Tabular related models, reinforcement, natural language models, multimodal model, computer vision. What is a multimodal model or LLM? LLM means large language model. Those will work for only text. But whenever you have image, video, audio, data, those LLM models cannot work. There we have a multimodal model. So here you see Gemini 1.5 is multimodal model. ChatGPT 4o is multimodal model. Okay, not the 3.5. 3.5 can understand only text. This ChatGPT. The ChatGPT can understand only text. But multimodal model, this 4, GPT 3.5 only text based. But 4.0 or 4o is for text, image, audio, video. It can take anything. Okay. Got it. So what for these models? GAN is mainly for generator and discriminator. We will be discussing what is this generator and discriminator. Diffusion model, where we have multiple like a DALL-E for images, style diffusion for videos, style gen also for videos. You can prepare text to video, video to text. Variational autoencoder, image generation, data compression, anomaly detection, drug discovery. So this is one of the large language model or multimodal model. This is the main context or purpose of this model. This model is good for these activities like image generation, data compression, anomaly detection, drug discovery. Anomaly detection means, let's say there are diagnostic reports, so you want to identify anomalies. You can use this variational autoencoder. This is mainly used in pharma. Flow model is mainly used for statistics. So these are the open source models. What we just now we discussed 4.4. Open source models means any public can access these models. GPT-4, GPT 3.5, Copilot, Gemini. Just now I showed you Gemini and GPT. Perplexity also. Then Cody also. Now Cody is here. Perplexity, I'll show you this one. This is the Cody. This one is the Cody. Okay. This is the Cody. It can prepare automatically code and everything. We are going to experience this one. Another one is which I showed you, Perplexity, right? I'll give you that link also. I can take a Perplexity also. This is also very powerful and popular. Yeah, this one. I'm giving you this link also. Take this link also, please. So I gave 4 platforms. One is OpenAI, another one is Hugging Face, another one is Google, now Perplexity. Are these 4 platforms? We keep referring these 4 platforms. Have you saved it? Okay.
Okay. Question, Sri. I'm sorry to interrupt.
Right, no problem.
Okay. What is the significance of each 4 links that you shared?
Significance means that those are the LLM models repositories. So we'll be accessing our models from there.
Okay. Yes, I mean, Hugging Face is definitely, I could see, models. And the second link that you showed, it's a studio, right? Looks like, Google Studio something.
Yeah, Google should. There also we have models, right? Have you not seen this one? I opened this one and showed you, right?
Oh, I
These are,
should go to the models. Okay.
I have already explained you this one. Okay, here also. Look at this one.
Okay.
Okay, here you can see models. Got it?
Yeah, I'm just checking.
Okay. Look at my screen. We can check later also.
Okay.
So yeah, these are the use cases of your generative AI. It's of course now part of every domain. So these are the benefits. We have already been discussing these benefits and all. So when these are all general statistics, we don't require that. Any questions here?
Yeah, I have one question. Hi, this is Shantan.
Yeah, Shanta.
So yeah, there are lots of GPT models available in the market, right? So like, why do we need to create a separate model? Is it because we need to,
We are
if there
not
is a specific
creating. We are not creating any GPT model. We are creating generative AI model. We are going to solve a problem by using these GPT models.
okay,
But
yeah. So there are lots of LLM models, right? So like,
we are
if
not
there
going to
is a
create
specific,
another Gemini Pro, another GPT-4o. We are not creating those models. We are going to use those models, solve problems by building generative AI models. Got it?
yeah,
So, but still, there are many organizations, they don't want to depend on like Hugging Face models or OpenAI models or Gemini Pro models. They are preparing their own LLM models, their own GPT models. All top companies, whoever have good money and good infrastructure, they are building their own LLM models. Got it?
yeah, yes.
Let me know any questions. All right. So let's move on to the machine learning part. So big data challenges are mainly three types. One is the storage, another one is analytics and process data science, then another one is reports or visualization. These are the three main techniques or these three main areas where you are going to work, where we are going to work, either be it a engineer or architect or manager, developer, it doesn't matter. So cloud computing is nothing but using infrastructure as service, platform as service. So your software as service, you all know that all these components can be accessed through internet, over the internet. Okay, that's a cloud computing. So these are the three main components of cloud computing, like infrastructure as service, platform as service, software as service. So these are the main benefits of cloud computing, like reduced IT cost, managed by experts, secure environment, 24/7 monitoring, very, very less downtime. So because of these reasons only, everybody is moving towards cloud computing, because it can be accessible from anywhere. It can be scalable up and down, database or computations, doesn't matter, whatever it is. These are the cloud providers: Google Cloud, Amazon Cloud, Azure Cloud, Databricks Cloud. Okay. Types of cloud: private cloud, public cloud, hybrid cloud. Then those are the general concepts what we have to have an idea before we move on to machine learning. We discussed that deep learning is a part of machine learning. Machine learning is a part of artificial intelligence. So what is artificial intelligence here? Transferring a human intelligence to objects, where objects can talk to each other or objects can talk to human beings. So that is our main objective. Whatever we are doing, that we are trying to replicate with the help of artificial intelligence. The humans wanted alternate for their activities. That is where AI came into picture. Okay. So that can be achieved with the help of machine learning and deep learning algorithms. So what are the different types of AIs? We have narrow AI. It is very, very small applications like chess games or recommendations or movies. Some specific tasks, small tasks. Another one is general AI. It is more frequently used one. Like this is where you are going to have a human-like intelligence capable of understanding and reasoning and learning across different domains. Then super intelligent. This is again a next version of general AI. This is mainly used for satellites and very mission critical applications. But most of the times we'll be working with general AI. Working with general AI. So these are the techniques of AI. The one intelligence can be added with the help of rule-based also that we have been working with. Normal program is rule-based program. Then machine learning. The AI systems can learn from data, improve their performance over time. NLP, natural language process. Systems understands, interpret, and generate human language. Then computer vision. AI systems that can analyze and interpret visual information from the real world. Okay. So what is a machine learning? We discussed artificial intelligence can be achieved with the help of machine learning. So machine learning is, machine is nothing but computer. Learning is nothing but execution that is done by algorithm. Algorithm will run against the data over and over repeatedly until certain set of predefined conditions are met. There are some predefined conditions defined. Until those conditions are met, it will keep executing. Machine learning algorithm will keep executing. So, but how many times it is going to execute, that we will not be knowing. Based on the data, based on the algorithm, it will keep running again and again, again and again, again and again, multiple times. That is called iterative. Iterative algorithms. Machine learning is iterative, but normal programming, if you write a C program, COBOL program, or any Java program, .NET program, any program, you just write once, it will execute once, it will take some input and generate output. That's all. That logic will execute only once. But here in machine learning, the logic what you define will be executed again and again, multiple times, the entire program without any manual intervention. That is called iterative. So, but until predetermined conditions are met, or learning algorithms are generally run until the point that the final analysis results will not change no matter how many additional times you run the algorithm against the data. That means you have executed an algorithm some 10 times. You got some output. Okay. After 10 times, it is again trying to execute 11th time, 12th time, 13th time, 15th time continuously. But you are not seeing any change in the results. It will stop. The model itself will stop. You don't need to execute it. So that is called iterative machine learning algorithm. Got it? Any other questions? Did you all understand this? What happened? Everybody is silent?
Yeah, let's move ahead.
Okay. So machine is nothing but a computer which learns, refers algorithm that will keep executing against the data until predefined conditions are met. Okay. So now the machine learning types are supervised learning, unsupervised, and reinforcement learning. So these are the three different major techniques of machine learning. Anybody who wants to prepare any machine learning algorithm, either they have to prepare in supervised, unsupervised, or reinforcement. There is no other place, other variety, other type. Okay. But again, within each, we have multiple. Under supervised learning, classification, regression. Classification like Navier-Bayes, decision tree, random forest, k-nearest neighbor. Then regression, linear regression, support vector mission, decision tree. These are the different types. Don't worry about the naming convention. Unsupervised learning like clustering, k-means clustering, okay, hierarchical clustering, then reinforcement, decision making, Q learning, R learning, TD learning. So these are the different techniques, types of machine learning algorithms. But most famous one, supervised, unsupervised. Within this again, linear regression, logistic regression, k-means clustering, random forest, decision tree. These are the most popular ones. These are the usages of each one. Unsupervised learning is like a compression, data visualizations, recommendation systems, segmentation market. These are the unsupervised. Supervised learning, image classification, customer retention, forecasting predictions. Reinforcement learning, robots, real-time decisions, skill acquisition. These are the examples. All right. So what are the key components of any machine learning algorithm which you take? So far, any questions? All are good? Fine. Right? Okay. Now let's see key components of machine learning. Features, where we have input variables or attributes used to make predictions or decisions. Features means input variables. The data, actual data points. I will show you those data points. The features. Here, if you see my screen, here you can see. This one. These are data points. Some of these above this you can see columns. Some of the columns can be taken as input variables or features or attributes. This one. Features, input variables or attributes used to which are there to make predictions or decisions. Then label is nothing but target, what you want to achieve. Target variable or output variable which you want to make a prediction or which you want to classify it. The model, mathematical representation or algorithm which will learn patterns from the data. Just now we discussed algorithm which is already executed on the data, that is called a model. Model means it has some intelligence in it. It's already trained on some data. It can understand the data. It can respond to your input. So internally, you will be having a mathematical representation or statistical representation. Loss function. So this is kind of a measure how well the model predicts the target variable. That means this is the difference between actual and predicted. That is called a error, actual and predicted. So our main objective is to optimize your algorithm by reducing this loss function. That means the difference between actual and predicted must be less. Okay. So these are the main components which we need to understand whenever you are working with machine learning algorithms. Features, labels, model, loss function, optimization algorithm. Any doubts? Oh, anyone please share the link. It's already there in the drive, right? Yeah. Question.
No, I just switched up my device, so
Fine.
expecting the link again. Thank you.
Okay. No problem. Got it. So these are the key components which we need to have. That's where we are going to work hands-on also. The feature engineering. Features means you cannot derive it just like that. There is a selecting activity, there is a transformation activity, there is a creating a new feature activity from your raw data. The whatever data you see may be a raw data. So you will have to derive data which you want. You will have to derive data which you want. Okay. That's where we call it as a feature engineering. We will be applying a different types of techniques and select, transform, create new features. So that's where we do the data pre-processing activities, feature selection activity, dimensionality reduction activity, feature scaling activity. That means increasing a feature, decreasing a features and all. These are all part of feature engineering. So we will discuss with hands-on also. The model evaluation. See, my request is everybody, you need to connect with the laptop. So we will be in 2 or 3 days, we will start hands-on sessions also. Model evaluation and validation. So here, whenever you write a model with some logic, someone should be there to test that model. Someone should be there to say this model is 60% accurate, 70% accurate, 100% accurate. That is where we have statistics like accuracy, precision recall, F1 score, area under the receiver, operating characteristics, ROC. So these are the statistical methods, a statistical formula where you can evaluate your model, validate your model, can decide whether model is right or wrong. Okay, whether model can predict correctly or not. There are some of the techniques also like a train test, splitting the data. We'll be discussing more on this one, training data. Okay. So these are some of the key terms which we need to understand before you getting into coding. Feature engineering, model evaluation, validation. Hyperparameter tuning. So I told you hyperparameter tuning means these are external parameters. There are parameters for LLM models, large language models, machine learning models. But here we are discussing machine learning, related to machine learning. Machine learning is learning rate. This learning rate will be depending on hardware, will be depending on volume of the data, what you are preparing, will be depending on the model complexity. Okay. And another one is regularization strength. So these are the external parameters which can influence the model output or model fine tuning. This is the one of the techniques to fine tune the model. Assume that you prepared a machine learning model. That model is predicting 60% right. Then your client will come back to you and say, "Boss, there is 60% not sufficient. So we require a 75% accuracy. So you need to increase the model to another 15%. Where are you going to work first? First, you are going to work on hyperparameters. Is there any chance to tune hyperparameters like learning rate, regularization strength, or model complexity? So first you sit on these parameters and you start working on these parameters and evaluate the model again. This time you may get some 70%, or you may achieve 75% also, what is client asked. And you stop there. But still they say, see, you are getting a 65%, still another 10% need to be increased. Then you have to go into internals of machine learning, like a coding techniques and what kind of algorithm you built. Okay. So, and what is the volume of the data which you are going to provide. So these things will come into picture still if you want to improve the model accuracy further and further. Got it? Then another parameter which we need to see is bias variance. Any machine learning model will tend to bias. There will be a lot of bias in machine learning model because there is no human in these machine learning models. There are more chances of biasing the output. Okay, that's where we will be working on unbiased models, preparing unbiased models. Okay, so this is about reducing error in the model complexity or simplifying, that is error due to oversimplification that can cause bias. Error due to model complexity that can also cause bias. Okay. So too much data, correct data will cause overfit. Less insufficient data will cause underfit the model. Remember that. So these two are the biases, overfit and underfitting. Any questions here? No questions? Very good. So here we have a different techniques of supervised learning, unsupervised learning. Supervised learning involves training the model, and that's where we call it as a labeled data set. What is a labeled data? Labeled data means the data which you are going to supply, which you want to achieve, is known. For example, I will give you fruit basket of apples, bananas. Same example I gave before also. Bananas, you know how apple looks like, grapes look like, mangoes look like, right? So you will be able to identify. That means here labels are given. I'll take another example also. You are given a products, different products like TVs, mobiles, laptops, okay, a fridge, microwaves. You are asked to categorize them. You know how microwave look like. You know how fridge look like. You already have the data, historical data. So you already learned about fridge, learned about your microwave, learned about your laptop, learned about your mobile, correct? So with the data, with the historical data, or from your parents, or from society, or from teachers, right? So that is called a label data. That is called label data. So whenever you have that kind of label data is available, you go for supervised learning. So every machine learning model will have a target label. So in supervised learning, there will always be some relationship between label data and target data. How and what is this one? Let me explain this one. So here I'm going to take a look at this one. Y equal to f of x. So we know that y is depending on x. If x changes, y will change, correct? So I take one example. Time is function of distance, one of the parameters, correct? So time is a target variable. D is label data or features or input data. If D changes, distance change, time travel also will change. Height and weight, price and quantity. Can anybody tell me some examples here where you see input and output relationship? Can anybody give me an example? Anything?
Speed and distance.
Yes, speed and distance, of course. Perfectly all right. So wherever you see a relationship between two variables, that is going to fall under supervised learning with the labeled data. Got it, Srinivas? Any doubts? Srinath, Srinivas,
I'm good.
Sayant.
Thank you.
Yeah, I'm good, sir.
Sayant? Sayant, are you there?
Yeah. I was just thinking first we need to get the data set right. Then we can analyze whether the
Correct.
target and label and labeled data
But
will be same, right?
No, but without even data set, first you will decide the target, right? Without deciding
Yeah.
the target, how will you decide? What you want to
Yeah.
achieve? That is a use
Yes.
case. That's the result you need to identify. Your problem statement.
Yeah. If the use case first you have to analyze and then understand right whether it will be
Ah,
unsupervised or
once you
supervised or
have,
reinforced.
yeah,
Yeah.
that's what I'm saying here. Once you have these parameters, that is supervised.
Okay.
We are discussing the concepts.
Okay. Yeah.
Okay, once you have label data given, then that is called target variable. So I told you goal of supervised learning is to learn from mapping functions from input variables to output variables. Just now we have seen time and distance, speed and time, like that. Model can keep the target variable for a new unseen data. Within the supervised learning, we have multiple types like linear regression, logistic regression, decision trees, support vector machines, neural networks. These are all the different varieties.
One more doubt, this is part of machine learning, right? So machine learning only deals with numerical data and it does not deal with text, speeches, messages. So supervised learning, inside supervised learning, if we get a numeric data or the problem statement that
Numeric data.
suppose we need to find out the number of apples which have got spoiled.
Yeah.
So then we got the data set and then we can then prepare the
Yeah.
model, right?
Yeah, that is called defect, identifying defect. Yes.
Okay.
Okay. We will do that practically. Okay.
Yeah.
So these are all the different techniques. So let's see first linear regression. So we have already discussed part of it. The statistical method, which is kind of a model where you see relationship between dependent variable or a dependent variable and independent variable. This independent variable can be one or more than one. What are those? X is independent variable. Y is dependent variable. If X changes, Y also will change. So this is only one independent variable. Simple linear regression. Now I can have multiple also. Here fx1. Then function of two variables. fx2 are three variables. Like this. Okay. So this is multi-linear regression. Why linear regression? Regression is nothing but relationship between target and input. These are the input variables. These are the input variables. So whenever there is a relationship between target and input variables, that is called regression or linear regression. Okay. If it is only one independent variable, simple linear regression. If there are multiple input variables, multi-linear regression. Got it? So it assumes that there is a linear relationship between the independent variable and the dependent variable, which can be represented by a straight line like this. That relationship is linear. Between independent variable, dependent variable is linear. Wherever you see linear relationship, that is called a linear regression. These dots are the data points. When you draw the line, this line should connect more data points. Wherever you see more data points, that is called best fit line. Best relationship maintained. Strong relationship is maintained. So you don't see here in all the ways a strong relationship here. Let's say you are categorizing fruits. Fruits categorization, color may not be. Now you tell me which one is most influential, color or taste? Tell me. Color or taste?
Taste.
Taste, right? Taste is the more unique one, most of the cases.
Yeah.
Color may be similar in most of the fruits. So that is where you see the strong relationship with the target variable or not so strong relationship with the input variable. That strongness we are going to showcase in the form of line. Regression line, how close they are. So this is the best fit line. These are the data points. The data points which are from this far from this line, we call them as outliers. We will discuss that concept, outlier concept, in a couple of classes. So today we understood what is machine learning, what are the different types of machine learnings. Under that supervised, we have taken a supervised learning. Within a supervised learning, we have taken a linear regression. Fine. Now, I want to implement linear regression algorithm in my programs. How do I implement it? What are the minimum basic steps which I need to follow as a layman? So one is import the required libraries related to machine learning. Another one is read the data using a pandas libraries. We will discuss what is pandas and all. Just have a concept in your mind. Steps. Distribute the data into X and Y axis. Split the data into train and test. I'll explain what is training data, what is test data. Fit the model and make the prediction. Attach this data to the model and make the train the model. Then predict the model. Then visualize the data using Matplotlib. Matplotlib means visualization techniques, showcasing the output to the user. So these are the minimum steps which we need to follow. Of course, you can derive any number of steps, but these are the minimum basic steps which we need to have to build a linear regression algorithm. To build linear regression algorithm. Got it? All right. So how linear regression algorithm works? There is a dependent variable, independent variable, fine. Dependent variable can also be called as target variable. This is the actual outcome which we want to predict. The independent variables called predictor variables are any variable which will influence the output. Okay. Or the factors that may influence or predict the outcome. Simple linear regression, I told you, if there is only one independent variable, that is simple linear regression. Multiple independent variables, multi-linear regression. Got it? This is an example. Predicting the salary of an employee based on their experience, years of experience. So now you will need to decide the data, which is independent variable, which is dependent variable. Independent variable is years of experience. Based on the years, your salary will change. That is dependent variable. Okay. Then you gather the data, collect the data, years of experience, corresponding salaries or employee historical data. Then we do linear regression line. We identify best fit line. Then we do the evaluation of the model, we do the predictions. We will do all these things practically. Okay. So this is about linear regression. So we will stop here. So tomorrow, day after tomorrow onwards, we will start working on hands-on. Okay. Any questions before that? Let me stop recording.